are at our second to last lecture for the survey, and today's speaker, Jeff Rothschild, combines elements of many of our past speakers, all in one package. He's a successful entrepreneur and founder, having sold and taken companies public. He's worked with the top hard and software companies in the world, and now he's with a VC. So I feel like that combines a lot of the different people that we've heard, although he's a different person. I built Jeff as the first VP of engineering at Facebook. But what's been fascinating about that is he started at Facebook, as far as I know. This is a small caveat. There's a lot of information on the internet, and I use it often to pull introductions. But it is always fantastic to actually talk to somebody because it's not all accurate. So put that in the back of your mind as one of our learnings. But he did start at Facebook in 2005. And at that point, I think that there were about 3 million the Facebook users. And they were mostly college campuses. And as you all know, I think it was this year, Facebook hit into the 1 billion user realm. So really way back in the beginning as the first VP of engineering. He's still at Facebook as an advisor. And prior to Facebook, he successfully co-founded Veritas, an enterprise software company. Veritas was then sold to Symantec, which I constantly mispronounce. Symantec. But what's interesting is it was actually sold in 2005 for $13.5 billion. I feel like in today's day and age, we throw numbers around all the time, and 13 billion may not sound huge, but we did have Yoki Matsuoka come, and she was a co-founder of Nest, which was sold to Google for $3 billion, which is huge. So if you can imagine 13.5 billion almost 10 years ago is pretty darn huge. He also co-founded a consumer gaming company, M-Plan and Hear Me, best known for, I'm not a big gamer, so let me see if anybody's played Command & Conquer. All right, Rogue Spear and Quake. Mind you, I was like nervous about even saying the name Quake. I don't know, I get a little superstitious. Prior to that, he founding those companies, he had his stint working in the corporate side, working in hardware. He worked with Intel, Honeywell, and was consultant to Philips. And I think he'll be talking about that a little bit as well, and has been able to travel around the world with those companies. Today, he's with Excel Partners, a venture and growth equity firm, funding companies from inception to growth. And you hear a lot about different venture firms, but what strikes me about Excel, and you may or may not know this, is that in 2005, they were the company that kind of took the big step to invest in this guy who dropped out of Harvard, Mark Zuckerberg, and they invested $12 million. If you can think about that, then basically, I believe Excel, and correct me if I'm wrong, probably had the best investment of any venture capital firm to date, unless there's something else that you know of.
One of the best.
Yeah, one of the best. And then I guess they invested in that other small company, Groupon, which has been doing incredibly well as well. So please join me in welcoming a man of many lives, Jeff Rothschild.
Well, thanks for coming out tonight. And in case anybody asks, it's no relation to the wine or the banking family. So, and I have a confession to make. When I was in school, I hated lectures for two reasons. One is I could read faster than anybody could talk. And the other is I couldn't skip over the parts I wasn't interested in. So I'll do my best to both speak fast tonight and to vary the topics a lot. So we'll jump around a little bit. So, when I was 18, I had it all figured out. I knew exactly what I was going to do. I was going to be a psychologist. I'd get a couch, a chair, hang out a shingle, and shrink people for a living. So I majored in psychology when I went to Vanderbilt. And that's me when I was 20 years old, being interviewed by a 21-year-old Oprah Winfrey. And I'd like to say that she wanted to talk to me about the Fortran statistics software I was writing at the time. But the truth is, it was about a course in human sexuality that the psych department offered, and that was considered very scandalous in 1970s Nashville. So I was writing software, and this is how I wrote it. Actually, I'd write it longhand. Everybody did, and then you'd go to a card punch and punch out a code deck, feed that deck into a machine. And one day I'm in the computer center running all sorts of numbers about some play behavior study. And I looked up at the monitor and I saw the status of my job. And the job had to allocate memory. It had to allocate disk space, temporary space. It needed a certain amount of CPU allocation. And then my job got up and it ran. And I looked at that and I said, there's way too much magic going on there. As a psych student, all I knew was how to write Fortran. And I said to myself, looking forward, over my lifetime, there's going to be two kinds of people in the world. And I still oversimplify things, but it would be those who would use computers, which I figured would be everyone, and those who actually knew how to build them. And I decided that day, just standing there running my psych data, that I was going to be in that latter camp. I had to finish my degree in psychology. I was a senior at that point, but I enrolled in graduate school in computer science. I just had to put this up. I hear the term code reuse a lot. To me, code reuse still means that you take code out of one deck and you move it to another. And after you're done using it, you had to return it. A silly thought, but the world simply has changed so much in 30 years. So probably the most interesting project that I had when I was in grad school was when my advisor handed me the Texas Instruments 7400 series data book and said, and an instruction set for a computer. He just wrote out an instruction set and he said, build this machine. Don't use anything other than SSI. So only small gate packages, as what's pictured here, the quad NAND package. And he didn't really teach a course. He was there to take questions, and I built that machine, and then I built a simple operating system and a simple compiler. And one day, it just occurred to me that the machine wasn't magic anymore. I sort of thought I knew how it worked, so I dropped out of school. I left without the PhD, which is the program I was in. I did petition the school later for a master's degree, which they nicely granted. So when I was a grad student, I actually knew I was going to be an entrepreneur. In fact, I told everybody that. It was the one reason that I didn't feel like finishing the degree. I figured that my customers wouldn't know whether I'd finished or not. So I knew I'd be an entrepreneur, but I hadn't a clue what I was going to build. So I figured maybe take a job and give myself some time to actually know something, because I truly had no feeling as to where I could go. So I took a job at Honeywell. And before I even got there, the fellow who had interviewed me had moved over to Intel. I got a call from him a few months later, and he said, we have an interesting problem here at Intel. We've built a solid-state disk emulator that's slower than the real disk, the physical disk it emulates. And I talked to him on the phone a bit and said, well, that doesn't make any sense. It must be a problem in your firmware. I bet I could rewrite that firmware so it wouldn't be slower. So we agreed that I'd start in 2 weeks. I quit Honeywell. And then the next week, I looked in the newspaper at the time called Computer World, which was a trade rag, and I saw an article with an interview from the general manager of this division. And in that article, he did acknowledge that all of their machines had been returned, but because they were too slow. But they had a solution to the problem. They had new firmware. It was going to be released in a month, and this had all been solved. So I called up my friend and said, well, do you still need me to come? This has been fixed. And he said, well, no, actually, I told the GM that you could fix it. So they're just pre-announcing your software. Well, I didn't know a lot about hard liquor at the time, but I knew I wasn't going to get to sleep that night. So I picked up a bottle of cognac on the way home from work. About 3 or 4 weeks later, I had figured out what the problem was. It was actually one line of assembly language that they had gotten wrong, fixed it. But by that point, I knew a lot about cognac. I'd sampled most every brand on the market. So I was at Intel. It's a great company. They had really amazing projects to work on, interesting computer architecture problems. But I wasn't happy. And it took me a while to figure out what was missing. What I missed was the tension that I had felt when I was confident that I was going to fail, and I was up all night, sweating about this project. I knew Intel was going to succeed with or without me, and I really missed that fear that I think is in the tension that was part of the startup process. I thought back to how I always wanted to be an entrepreneur, and I left Intel to form a company that was called Tolerant Systems, and I list that in the failure section, because I was looking for that fear, I was looking for the risk, and I certainly found it. I had a lot of projects that failed. The universal printer cable system solved the problem of a computer store that had 10 brands of PCs and 20 brands of printers, and they had to stock way too many cables. So I had a cabling system where you could just plug in the right cable adapter on each end, and I got that to market just in time for IBM to release their PC and their printer, which the industry stabilized around and conformed to. Similar projects where I learned a lot of really interesting lessons, and some of them were expensive lessons, and some were expensive for people who were foolish enough to invest in me. But these were really some phenomenal projects, and I don't really consider them failures because they contributed so much to what I've learned. And occasionally some things worked. Veritas Software actually rose from the ashes of Tolerant Systems. So there's a little bit of failure in that success, or some success in the failure. Veritas grew to about 5,500 employees, about $2 billion a year in revenue. And at one point, we were worth about $70 billion. But that point was 1999, and that's sort of the steroid era for company valuations. You have to put an asterisk next to that, because it really didn't count. And as was mentioned, the company did sell later to Symantec. Empath was a gaming company, and we did the first online version of Quake and worked with id Software to make that happen. Command and Conquer. Some really great titles, Total Annihilation from Cavedog. It was a blast, most fun I think I've ever had in writing software. However, we were a bit early for the market, and the company, while it did go public, we had a $800 million market cap at one point, it's not around today. And companies really, you have to build companies for the long term, and we didn't in this case. Late 90s, maybe year 2000, my wife asked me, to sort of hold back on starting anything for a bit. She was getting tired of the 100-hour work weeks, being up all night working on this or that. And I promised her, I said, okay, that's it. I'm going to just mentor younger entrepreneurs. I'll be a coach. So a very minor level of investment in the projects. Well, one of the first projects I was introduced to were a couple kids from Harvard, and that was Mark Zuckerberg and Dustin Moskovitz and their other roommates. I was asked by Excel Partners to help hire a VP of engineering, and I kept bringing people into the office, but in the meantime, I couldn't help but sort of pitch in a little bit and get involved in the engineering process. And I also started reading the inbox for the company, the mail that the users were sending. People told us that it made them happier. And I actually saw love letters and poems that users had written for us, or for the company. At that point, it wasn't really me, but I was just fascinated by this. And I thought back and said, well, Veritas was a big company. We had thousands of customers, but no system administrator had ever written me a poem. So there's got to be something really, really special about this. Long about then, Mark probably got tired of the people I was bringing in for this as a recruiter. He said, you're a lousy recruiter. Why don't you just do this yourself? And I started working at Facebook. A couple months later, I didn't really tell my wife at first that I was really diving in head first, but she got up at 2 or 3 in the morning and saw me rebooting machines and poring over code dumps and said, in the morning, remind me to ask you what the difference is between this and a startup. And of course, there was none. The excitement was there, and it was a tremendous project. So through all of this, I think I've learned a little bit about entrepreneurship. Probably the most important lesson I learned is that you've got to be part of a team. If you play a team sport as an individual, you're going to lose. Michael Jordan is going to lose to any high school basketball team. Teams let you move faster. And moving fast really matters. It matters for so many reasons. We're going to go into that. Teams give you the aggregate knowledge of the people on your team, and teams give you immediate feedback. There's a lot of value in somebody who can just simply tell you, you're full of it. That isn't what we're doing. Another lesson, do what you're good at. I made this mistake on one project. I'll spare you the details, but I attempted to build not only the software, but also all of the hardware. And it actually worked sometimes, and some of them came off the manufacturing process okay, but not enough to ever make a profit. It's a tough lesson, but be what you're good at. Do what you're good at. And if you find that you can hire somebody who's better at you at what it is you're doing, well, fire yourself. Go ahead and hire them. And do something else, because there's probably something more valuable in your project that you could be doing. This is something I've seen over the years. People let their ego torpedo them. There's countless people I know who took a job because it offered them a fancy title. It wasn't really the best use of their talent. It wasn't the greatest, where they were going to have the most impact. It's a mistake to believe that your resume is going to be built based on the titles that occur in your resume. It's not true. Your resume is built by the success and the impact that you've had, and it has nothing to do with title. But that people chasing titles has been, a very sad story for a lot of people I've known. And again, do what you know. You want to have every unfair advantage you have. And if you're working in a domain where you're not the expert within that domain, then the deck is stacked against you. So what are some of the attributes of a successful entrepreneur? Clearly, focus, motivation. You have to be dedicated to building a business, not proving you're right. The focus is clear. This can't be a sideline. You have to know your strengths and your weaknesses. So self-awareness is really key. And again, that domain knowledge. If people have that knowledge, then they have an advantage over everybody who doesn't. And intellectual honesty, and we'll say more about that. This is not honesty in the common sense of not telling the truth. It's about not fooling yourself. So you don't want to confuse optimism with wishful thinking. They're very different. So you need to be open about your limitations, the limitations of your team. If you're not open about that, then you'll just fall into traps. You need to be open about the challenges that will meet you in the marketplace. And it's really interesting when you go out to raise money for a company, or you're trying to recruit other people to join your team, there's going to be a lot of questions asked of you. And the right answer for anything you don't know is, I don't know. Because saying you don't know says that you're aware there are things you don't know, and that these are holes that you can fill in. If you don't know that you don't know it, then you're just going to blindly move on. So your investors are more impressed by people being honest about their limitations, about what they know about the risks that are in front of them, or what they don't know about those risks. So nothing turns off an investor faster than somebody who pretends they know it all, and then the investor says, well, we live on different planets because your view of the world is different than mine. So ideas versus execution. Okay, so the slide's a joke, but the point is deadly serious. There really is a difference between ideas and execution that is profound. Ideas, as we know, are a dime a dozen. Unrealized ideas are worth even less. So this graphic probably does a better job of conveying a well-executed idea, because the idea of landing on Mars is easy, and we all could think of that. Pulling this off was an amazing feat. So we've all had that experience, I'm sure many of you have, of seeing a product and saying to yourself, I thought about that. I mean, that's not uncommon, because our minds are ranging, and sometimes you think about things. But the next time that happens, stop, pause for a moment, and then ask yourself, why didn't I do anything about it? Why didn't I build it? And there can be really good reasons you didn't. You may have been working on something else, and so there's the opportunity cost of dropping what you're doing. It could be that you didn't really have the expertise or the domain knowledge to dive into that space. Often good reasons not to, but go through the exercise, ask yourself, have that discussion, because it can really help inform you as what to do the next time that you do think of something and say, wouldn't it be neat if this existed? So the best advice I could give to any entrepreneur is just do it. It doesn't matter if you win or you lose, you're going to win. You're going to get value out of the process. And doing things says a lot about you. Conversely, not doing says a lot about you as well. So put yourself into the role of an investor for a moment, and somebody comes in to pitch you on a project. What do you want to see? Do you want to see a prototype, or do you want to see a PowerPoint? Do you want to see a product demo or a business plan? Do you want to see someone who does or someone who talks? You need to put yourself in the doing category. And how do you do that? Well, you just do it. You attempt it. You build that feasibility study. Make something happen, because that speaks volumes about who you are. So these are terms everybody has heard. And at Facebook, you see slogans about learning fast, failing fast, and moving fast on every wall. But it's much more than slogans. It's really, really important. Moving fast reduces risk. And that seems counterintuitive to some, because there's the feeling if you didn't move, if you move fast, you may make mistakes. No, if you don't move fast, there's the competitive risk of somebody else moving faster than you did. There's the capital risk of the amount of money that you spend on something, to a large degree, is a function of the time that you spend doing it. And of course, there's the opportunity cost. You reduce that opportunity cost by doing it quickly. At Facebook, we have the slogan, move fast and break things. So if you've ever visited the campus, you'll see that everywhere. Actually, I should say it aside. When Mark used to tell each new engineer I'd hire, don't be afraid to break the site. I'd rather you crash the site twice every year than spend the whole year worrying about crashing the site, because you're going to get so much more done. And that worked up to probably about 100 people on the team. So he modified that to move fast and break things. We do test, and testing is really important. But the idea is there. Make it happen. Don't be afraid of making a mistake. Learn fast. The world's changing around you. If you stick to the assumptions you started with, they may not be valid 3 months later. So keep your eyes open. And fail fast. This reduces your opportunity cost. The objective is winning. It's not proving that you're right. So I've heard people say that everybody in the Silicon Valley has a business plan in their back pocket, sort of like everyone in Hollywood having a movie script in the back pocket. The only problem with that is that nobody uses a business plan anymore. So if you don't have a business plan, what do you do in order to think about your product? And the model that has worked for me is to tell a story. Telling a story about your product is describing how somebody would use it. Who is the customer? What are they doing now? What challenges are they facing? What are the inefficiencies that are resulting from the way they go about their life today? And then just write a narrative about how somebody would use this product. And it's going to inform you. It's going to help you fill in the details. And if that story is coherent, it's going to help you get funding for your project. It'll help you bounce that idea off of potential customers to help you refine this notion. At Veritas, which was software that made systems more reliable and made data storage more reliable, I would tell a story about somebody working in an auto factory who had to do an administrative task that would cause the factory to go offline for 3 hours. And then I would describe what that meant to them and the circumstances it would create for them and the relationship with others at their work. And then I would tell the story of how it would work if they used our software. That would resonate very well with the person who lived that experience on a weekly or monthly basis. It sounds pretty obvious, know your product, but know your product deeply. Not just superficially with the descriptive terms of what it is, but think about why people would use it. Why could it be useful? So again, taking the case of Veritas, was it useful to describe it as a volume manager and a file system, which is exactly what it was? Or was it more useful from a planning process and from understanding who the company was to think of it in terms of software that improved availability and data integrity? Was it useful to describe Facebook as a social network in 2005? Because certainly there were social networks. There was MySpace, there was Friendster. That moniker really wasn't very useful. But describing it as a social utility that would allow people to share efficiently with each other and to improve the connectedness among people who matter to you, well, that helped guide what we built and how we built it. So know your competition. It's rarely another company, I mean occasionally, but usually it's the way people solve the problem today. So at Veritas, it was people who didn't use Unix. They for whatever reason, there were very good reasons, they were still using proprietary mid-range platforms. At Facebook, I used to joke with people that the competition was not MySpace, it was the Christmas letter. Because if we did our job right, then nobody would bore you with a finely typed missive once a year that told you about everything that happened in their family, because they already would know what was going on with you and your friends because of the connectedness and the presence that the site allowed. Empath, the competition wasn't another company, it was actually the games themselves. And games today include their own community and networking support. This seems pretty obvious as well, but it's not. The key here is that you create a lot of value, and it doesn't really matter how many people you create it for, because you can't sell to everybody. You can't build a business that can support everybody today, so you might as well make things easier on yourself and be a compelling choice for someone. That someone should recognize that that product was really built right for them. And if you've ever thought about sales, it may seem easy, it's really, really tough. And nothing's more discouraging than have people not returning your call. But or when you do see them, they say, I've seen 5 of these this week. But if you're talking right to them and they feel that this product speaks to them, that's golden. And it doesn't matter how many of them there are. Fish in a small pond for now, but get a beachhead. So the size of the market is probably irrelevant, but the time to market is, and the cost of getting there is, and those costs can be constrained better by constraining the product initially. When you think about an idea and you're trying to judge, does this make sense? Well, simple typically wins. Simple to evaluate, easy for someone to try it out, simple to sell or distribute, easier to explain or understand, simpler to use. Any dimension of simpler often provides the basis for building a business. But conversely, if there is a simpler way to solve the problem than the one you're proposing, then really think about whether you're doing the right thing, because the advantage lies with simple. And you want that to be yourself. So let's simplify management. And I often, when I talk about this, I tend to insult the managers in the room because they would view management as being very complex. I tend to think of it as very simple, that there's really only one rule that matters. Optimize for the emotional engagement of the people on your team. If people care, if it matters to them, then they make the right decisions about how they allocate their time, their commitment to the product, their commitment to the company. And everything else you do is secondary. It isn't about schedules, it isn't about productivity. You don't optimize for those because those come naturally if people feel ownership of their work. So, this is an interesting issue because, best way to say this, a lot of roles in companies stifle this notion of ownership. So frequently when I've made somebody a manager, the first thing that they try to do is establish their credibility with the team. They want to still show the team that even though they're a manager, they're a great engineer. So there's a problem to be solved. You call a meeting, everyone comes in, and then the manager attempts to show how this problem will be solved. And they have the architecture in their head. They're as good an engineer as anybody in that room. But all they've done is made this process uninteresting for the people on that team. Because in 30 years of doing this and interviewing people who've had computer science degrees, I have yet to meet somebody who told me that the reason that they studied computer science, or engineering for that matter, was because they were excited about the idea of implementing other people's ideas. Haven't met one yet. But when you tell people what to do, you're effectively doing that. You're sucking the joy out of the engineering process. And that process comes from thinking of something, realizing it, and then bringing it into the world. So what the manager needs to do is, instead of telling the team, like, I know this solution, even if they really do know the solution. The best choice for them is to frame the problem and then step back. And if somebody proposes a solution that isn't the way they were thinking about it, ask some questions. Maybe those questions will cause that person to redirect their ideas a bit and bring it, let it fulfill all the requirements. Maybe the answer to those questions let you recognize that they had a better idea. But regardless, people will leave that room having ownership of the project. And the best rule of thumb when wondering how to lead people is say, well, how would I like to be led? We have 99% of the same DNA as a pig. So we're probably pretty close to the same DNA and the same values as another engineer. Achieving consensus. So, it isn't important. People ask me all the time, how do I get everybody on my team on the same page? Isn't going to happen. If you've got smart people on your team, they're going to have ideas. They're going to be thinking about the problem, and they're not necessarily going to agree. So trying to achieve consensus often has the effect of creating the expectation that that's both a desirable result and one that you should be working to achieve. What is important is being heard. I mean, think for a moment and just put yourself in this situation. You wouldn't work at a company that didn't care about your ideas, didn't care what your viewpoint was. If you were part of a team and there's an important decision to be made and you speak and no one listens, you walk out the door. However, it's going to happen all of the time that there's going to be a difference of opinion. And so a mature person is going to have the expectation that sometimes they get their way and sometimes they don't. And somebody who can't accept that probably doesn't belong on your team. They're probably going to be corrosive to the team. So it's key to be able to solicit people's opinions, make sure everyone is heard, and then make decisions in an open process where you acknowledge all of the differing opinions, recognize that they have value, and explain why you're going to move forward. You also need to build a culture that accepts failure. I worked at Honeywell for a little bit. And they built a project that every engineer on the team knew was going to fail, but nobody had the guts to tell management that it wasn't going to work. I was at Philips for a little bit as a consultant working in the Netherlands, and I came by there in 1983, and they were trying to decide what network to use, token ring or Ethernet. I came back in 85, and I asked someone, well, so what did you decide? And said, well, we haven't decided yet. We don't want to get this one wrong. For 2 years, their customers didn't have a network. It hurt them in the marketplace because there was this fear of being wrong. A culture needs to accept that sometimes you get it wrong. But it isn't okay not to know you got it wrong. So along with that risk-taking culture, you need to have measurement, you need to have analysis, and you need to have an open mind for accepting the fact that decisions can be wrong and then be able to change direction. The motivation of your people on your team clearly matters. They need to be doing it for the right reason. If they have a feeling and value your business, if they care about the business, they simply will do a better job. They'll require less heavy processes and heavyweight processes to manage them. You may be able to get away without having the product manager, where if you hire people who are just, engineers who had no interest in the business, you're going to have to write very detailed specifications for them to make progress. This is sort of important. Here's one I really messed up. It really is a business. So when I was in school, I actually slept through my accounting class. It was a room about this size. I was always in the back row, and I don't remember a lot about it. But a little bit of knowledge would have helped a lot. So if you're going to talk to investors, well, maybe pick up a book on venture finance so you simply know the process and you won't get surprised the wrong way. If you're going to ever manage a budget, well, take a few nights, learn your way around a balance sheet. And, the worst that can happen is it'll help you get to sleep. But it can be expensive. This is an expensive lesson for me. And again, spare you the details, but it cost me and some of my investors some money from having slept through that course. So a few thoughts now on building things. essential process. If there's something that matters to you in terms of your engineering process, then anything else you do takes away from it. There's no free lunch. So when you layer on new methodology, you're actually taking focus away from the methodology you have. And if the reason you currently have it is because that's the most important, then you may be net negative. So for me, the most important element of process is a serious review of code and a very simple description of the test plan, what could go wrong and why you know that it isn't. So another key concept, measure everything. The return on investment of measurement is immediate. It pays you back forever. So put some examples in here. If you call a service, so this is again a software example which reflects my background, measure how long it takes. It doesn't matter whether you have a problem there or not, just log this data. The data is going to be useful for you. The payback on metrics is indefinite. On the topic of measurement, averages really can get you into a hole. They hide information in so many ways. If you think about CPU utilization, averaging across time can hide non-uniform CPU utilization due to peaks, bursty behavior. If you average across cores in a processor, then you may hide multi-threading problems. So you may have a bad multi-threading model. If you average across machines within a pool, then you may be hiding the fact that you have uneven load distribution. And this is true for networking. It's true for when you're looking at switches. Any type of system that you measure, yes, it's okay to report an average, but P90, P98, P99 is really more valuable. And averages don't reflect the user's perception of a service. If 1 out of every 30 or 40 interactions is slow, you'll remember the slow. You won't remember the 29 that were fast. So it's the 97th percentile, 98th percentile that really does define somebody's perception of how something works. I think this is something that for those of you who are studying computer science, you've probably heard quite a bit about. Stability doesn't mean that it doesn't crash. Stability means that it converges on correctness. There's an assumption that what you're going to write is going to fail. There's an assumption that what everybody else writes is going to fail and be in broken states and will be hanging calls and be non-responsive. And your software is simply going to be calmly watching all of this chaos around it. And when the world becomes ordered again, we'll simply pick up and go. Complicated, simple concept, complicated to do. And I know that, that the Berkeley CS department is sort of a world leader in teaching this type of design. Trust nothing. Again, part of the same idea. It doesn't matter whether you wrote it, somebody else wrote it, whether it's a service you're calling from a well-known Valley company, it doesn't matter. Don't trust it. Assume it can use you incorrectly and assume that it isn't going to do what you asked. So put in that validation. What makes for a better engineer? I put up a couple ideas here. And my feeling is that you need both. But a little bit of humility, awareness that you will get it wrong, you can get it wrong, goes a long way towards getting it right. This is often what separates somebody who has been doing it a year or two and somebody who's been at it 10. The person who's been at it 10 has a little bit less confidence, actually, that they can get it done right. And it's simply, you deal with that by building in testing, validation, and doing defensive coding. It's not hard. It's impossible. So don't try. I put up, people often say that schedule is specifications times resource. It's blatantly not true because there's a right resource for any problem. So this is not a fundamental equation like some of the others I listed here. This is not, or I didn't put it up, but it's not like V equals IR. This is bogus. There is a right amount of resource. And so you could express this as time equals content times quality. If you're going to hold time and quality constant, because you do want to do it right, and there often is a time it has to be done. Well, go ahead and then build in stages, build iteratively, so that when the time occurs, you have something. This is probably the best proof of why iterative development makes the most sense. And there's 5 other ones having to do with always working on a stable base. But anyone who thinks that they can accurately schedule software is generally kidding themselves. So let me finish up with 2 ideas that I think everything I say tonight could be controversial, and you'll find really smart people who are going to disagree with me on most of this. But this in particular, I do think you need to learn more than you need to and learn it efficiently. So what do I mean by learning more than you need to? Very few people learn the complete stack. And again, I'm using a computer science model here because that's the way I think. So the complete stack would be all the way down to the hardware, and then the lowest levels of software, device drivers, the operating system, the language system, how the language translation works, the kind of code that gets generated. Very few people learn that, but the ones who do can solve problems that those who don't never can solve. So there really is value in learning the hard stuff. And learn inefficiently. And I'm showing my age a little bit in saying this. When I started working as an engineer, if I needed to learn more about the system I was working on, I had no choice but to read through paper manuals, and they would occupy this entire desk, a stack of books. It might take me 20 minutes to find what I was looking for. But in that 20 minutes, I might run into 50 other useful pieces of information that I had to scan through in order to find what I was looking for. So I like to call that collateral knowledge. So the documentation sets we have today, that hypertext documentation and our ability to search for any problem and find its answer, they rob us of the knowledge that we gain by bumping into the things that occurred along the way to finding our target. So at the risk of oversimplifying, and I do this a lot, so you've heard a lot of this tonight, everything I've said is somewhat oversimplification, but I always like to put people into 2 buckets, and I've had this idea for a while. There are those people who, when presented with a problem, their first reaction is to go ask someone. And very frequently, these people get the problem solved quicker. The engineer who, instead of opening that stack of documents or opening the source code and reading through the source code, they ask someone and they get an answer, they fix their problem, they move on. They did get it done sooner. The other kind of person, is the person who tries to figure it out themselves. They read the code. They might write some test cases to see what the behavior is, to understand what the compiler is doing, how the hardware actually behaves. The askers get there sooner, but imagine that you repeat this process 1,000 times. The people who figure it out are going to eclipse the askers over time, and I believe have more impactful careers and simply are more capable and are able to have a greater impact in the world. So I love hypertext documentation. I'm not telling you go do a linear sort through online manuals, but learn more than you need to, find all the information around what it is you were looking for, because eventually you're going to need that as well, and it's going to increase your understanding of the total environment in which you work. So thank you very much.
Coming over with the microphone for Q&A. I just want to thank you. You talked about the inefficiency, learn inefficiently, but I can't imagine a more efficient way to get so much information across. So thank you.
And let me again apologize for having said so much. I did move at a pretty high clip, but again, if you have to sit through 40 minutes of a topic you weren't interested in, that would be worse.
But it was like, a good 90 minutes of information.
Yeah.
So I'm happy to take questions, yeah. Or actually, I'm not taking them, Jeff's taking them.
Here, go ahead.
We just want to get it on the mic.
Hi, this is very short questions. What do you mean by rewarding failure in building a culture?
Sure. The natural behavior is to reward the people who were successful, who had the biggest impact. But if that's what you consistently do, who's going to join a project that is very high risk? Because there's real risk to their career, there's risk to their advancement, there's risk to their compensation. So in order to foster an environment that really does accept failure, you need to reward the people who worked on a high-risk failure project that ended up a failure, where the marketplace simply didn't accept it, or there were technical risks that couldn't be overcome. Because if you don't make a conscious effort to do that, then people simply learn the game. The game is work on the projects that will succeed. And those that have, but it's only the projects that have risk are the ones that can be transformational for a company. The safe projects really don't move the company forward. It's the risky ones, but human nature is to figure out the rules of the game and then play it. So that's what I mean. The company has to make a conscious decision. You worked on this total disaster we had. You did an amazing job, and have them get the same reward and the same recognition as somebody who worked on the product that just shipped and is beating sales records.
So you have this extensive background in engineering, but I think you had some pretty insightful things to say about leadership development. Do you think some of that comes from your background in psychology, that you have this leadership inside of you? Because the engineers and the leadership often don't get put in the same box, but it seems like they have with you.
I'm not sure. It could be that they're correlated due to a common cause. So it may have been my interest in psychology was that I had an interest in how people behaved and thought and what motivated people. I can't point to any one thing that I learned in 4 years as a psych major that I say I'm actually taking advantage of. So I'm thinking it's the latter and not exactly that.
So I had a question about, kind of similar. I think you had some really insightful stuff about management. I'm taking a class right now where I'm basically trying to manage my team because I feel like they're not pulling their weight. And I just realized holy crap, I'm doing it all wrong. And I just really want to hear more about you talking about emotional engagement.
Well, you have to feel ownership. And when I worked at Intel, I built a product. And they sold a lot of it, I think $250 million of this solid state disk. And they gave me a nice reward after that. But I didn't feel ownership of that product, if something was lacking. And that made me think about what ownership meant. That we don't really work for a company. We don't work for our manager. We work for ourselves. Someone who reports to me at a company isn't working for me. They're working for them. They have a reporting structure that said that I'm their manager, but if anyone works for anyone, it's me working for them to help them do their job better. I'm at their service, not the other way around. So if as a manager you feel that you lead people by telling them what to do, that's the fastest way to demotivate them. Engineering is about that creative process of thinking and then making it real. And you can't have that if somebody else thought of it. This job called an architect, many companies have people who say architect on their business card and others have engineer on their business card. I think that's a disaster. If there's anybody who has the job title architect, that must mean that everybody else is, it implies that they're a non-architect. And the non-architect is the doer, and the architect is the thinker. And that's not why anybody pursued this career. So in every company of mine, I have never allowed anyone to have architect as their title. Every engineer is an architect, and every architect is an engineer. And some people do a little bit more design and maybe less implementation, but everybody does some of something, some of everything. And in terms of people on your team being motivated, it has to be, they need to go to bed at night still thinking about that problem. And if they and get up in the morning eager to get out of bed and work on that problem again. And you only do that if it's something that feels like it's yours.
Question, just a follow-up, and then we'll have another one. But It's so hard. It's like you're talking about having a class where you have to like get people around a product and do something in class. Josh, is that right? So how do you tell a story in a way? Maybe that's. I'm curious to know if you can use a story or how one might use a story to get people motivated.
Well, the story, I've used that as a technique to refine the idea and to bounce the idea off of others. I just would build a narrative around a product. But the story helps everyone on the team get on the same page. Imagine working at a big company where somebody drops a specification on your desk and then says, implement this, build this. I can't believe that that's what anyone in here thought about when they picked their major. But that's often what happens in industry. And the biggest companies tend to have the most detailed specifications, and I think they have the least happy employees. So telling a story is a way of communicating the essence of a product, the idea, the motivation, so that everyone on the team has a shared vision. And specifications are imperfect. You can't describe every error condition. You can't describe every extraordinary condition within a specification. So unless everyone on the team has a common vision, you'll never have a coherent product. And that's where telling a story can be a useful way so that to build that common understanding.
Yeah, so Josh touched on the fact that it's not enough to just lay out specifications, and you mentioned the fact it's not business plan, it's not the framing the solution, but more along the lines of framing the problem and allowing engineers to understand that this is the problem and allowing them to undergo the creative process. And you kind of touched on briefly that you want to enable ownership, and for, I guess, people who are working with you or for you to have that kind of buy-in. And I know you mentioned that being able to frame the problem or the solution is a big factor, but besides that and telling the narrative, to understand the why, what else would you recommend to help, I guess, encourage people to spend X amount of hours waking up at 3 a.m. and have that be on their brain?
The school project is a little bit different. You have a lot of other demands. And I mentioned that one of the attributes of a successful entrepreneur often is focus, which is that there's nothing else going on. This is it. Their future depends on this. Their ability to be successful as an entrepreneur depends on this project. If you've joined a startup, your future is linked to that startup. And you're not thinking about career path. You're not worried about the title you're going to have at that company. You want the company's products to succeed. So in a school project, that can be a lot harder. There can be other courses that are stealing people's time. So I think you have to have a feeling that that this is yours. You're proud of it. You're going to tell your parents and your friends about it. It's something you want to talk about and feel as a part of you. And as the leader of a project, you have only one goal, and that's to ensure that every member of your team has some of that. Your goal is not to write specifications or divide up the work. Your goal is to ensure that there exists something in that project that each person can point to and say, that's my idea. That existed first in my head. And when we build this, it's now going to exist in the world. And I think everything else will take care of itself. So when I say that the first rule of management is optimize for emotional engagement, it's really for ownership. Worrying about schedule, worrying about product quality, deliverables, all of those are details. None of them will actually be successful unless you've done the first. And that first is what so often is not done, and is done poorly. Please.
Hi, Jeff. Thank you very much for the talk. I have a little question regarding when you said that it's very important to create a product that creates value for someone, right? For me, this is very contradictory with what you guys are doing at Facebook, which is like creating, a product that works for everybody. So I wanted to have more, insights on that.
I was waiting for that question because when I was writing it, I said, well, this is clearly contradictory because everybody knows that, Facebook's being used by, about 1.25 billion, 1.3 billion people today. Facebook is a rare exception. But even at Facebook, we didn't start building a product for everyone. It was a product initially for students at Harvard, and then eventually we became schools across the country. When I joined Facebook, we still weren't at every university. And for the first, let's say 2.5 years of the company, it was entirely about schools. First universities, and then we did high school. And then we did corporate networks, and then we finally released the product for everyone. So I do think that Facebook followed that model. If we just built a product from day one that was going to meet everyone's needs, I can't guarantee it would have followed the same trajectory. But it was a perfect fit for students in 2004 and in 2005. But the privacy model was very simple. If you went to Berkeley, then you shared openly with everybody who went to Berkeley. And if you went to Stanford, you shared openly with everybody at Stanford, just not anybody at the other school. That's a very simple model. When we released the product into the more general world, it was everyone in San Francisco shared, and then everyone in the South Bay. Well, if you lived in the South Bay, certainly you wanted to share every detail with everyone else there. If you lived in England, well, of course, every other Englishman should see. So we didn't have the product that really met everybody's needs. We focused on a market we understood and met their needs very well, and then moved on from there. So it's not as much of a contradiction as it seems based on where the company is today.
I am wondering if you would take questions kind of one-on-one, and I want to thank you so much for your time. If that's all right, if
Happy
people
to
can
do
come
so.
up. So thank you so very much.